Hello everyone. Today we will consider this problem. This problem is about finding the maximum value of the determinant of a matrix. This matrix is a matrix which entries can be 0 or pi. So we will obtain the maximum value and also will show an example of a matrix that achieves this maximum value of determinant. So at first we will consider the following application. So given that the elements of the matrix are just 0 or pi, then we can consider a matrix of the following form. So we will say A is equal to pi by B. And B is a matrix such that Bij is equal to 0 or 1. Yes. So we reduce the problem from consider 0 or pi to consider 0 or 1. So now we will construct such matrix. So B has the following form. B is equal to B11, B12, B13, B21, B22, B23. Okay, I'm just writing what is the more general form or a 3 by 3 matrix. Okay, in this case, what is the main thing here? If we make the expansion of the determinant of this matrix, what will we find? We'll find the following. So let's put determinant of B is equal to B11 by B22, B23, B32, B33. Okay, minus B12 by B21, B31, B23, B33, and also plus B13, B21, B22, B31, B32. Okay, here given that the BAG can be 0 or 1, then we will say okay, then the determinant cannot be a number bigger than the determinant of the 2 by 2 matrix of this form cannot be bigger than 2. And what is the reason why it cannot be bigger than 2? Okay, because if you consider these terms can be only 1 and 0, 1 and 0, so it will be this, for example, B22, B33 minus B23, B32. But these numbers can be these numbers can be only 1 or 0, and these numbers only can be 1 or 0 because they are we obtain them multiplying 0 or 1. So if we make the difference, mostly it can be 1. So that's why also we will have the following. We will have the determinant can be, sorry, I just erase this part so we have enough space for writing more. Then it's just equal to, if we make less or equal than 1 plus B12 by 1 plus B13 by 1. I'm producing an inequality, supposing that all the terms are positive. And also B11, B12, B13 can be mostly 1, so all of them is 1 plus 1 plus 1 equal to 3. So this is a possible bound, but there is a problem with this bound, as we will see. So how can we obtain this bound? This bound can be obtained if we consider like B11 equal to 1, B12 equal to 1, 2, and B13 equal to 1. These are the only possibilities because these numbers must be equal to 1. If not, they will be equal to 0 and they won't add anything. So what will we have here? So we'll have 1, 1, 1. Okay, now we have to complete these terms. The b21, b22, b23, b31, b32, b33. But in this case, we will try to obtain the form that will help us to obtain the determinant equal to 3. But in advance, we will see it's not so easy, even it's not possible, as we will check. So for this one, we will have that the minor matrix should be at least 1, 1 in the diagonal. Why? Because it must be 1 and the determinant of this minor matrix must be 1, 2, so we will multiply them and they will give us 1. We don't know what is the other terms in the anti-diagonal part, but at least we know they must be 1, 1. Okay, now for this term I will use green here. For this one, the same. So this at least the diagonal of the minor of this matrix must be 1, 1, as shown here. And finally, what is the requirement that we have to obtain for 1 here? So if we can 1, we can continue from here. So we will say, okay, this is x and this is y. What is property? We know from x and y that they must be 1 or 0. Okay, now let's expand this matrix determinant. So it's 1, 1, x, 1, 1, minus 1 by 1, x, y, 1, plus 1, 1, 1, y, 1. Okay, let me use another color here. Okay, then we will calculate this determinant. This is just equal to 1 by 1 minus x minus 1 minus xy plus 1 minus y. Okay, so let's make some algebra. We will have 1 minus x minus 1 plus xy plus 1 minus y. So we will make some algebra to here. Here we have 1 plus xy minus x minus y. So what is problem here? We have said that x and y can be only 0 or 1. So we know that this number is of course 1. And we know that this number can be 0, 1, but it can be equal to 1. We want it will add. But if this number is equal to 1, then x and y must be equal to 1 each other. So it's impossible because then they will be 1, and the final result will be 0. So we cannot have a determinant equal to 3. It's not possible in these conditions. So what is the next number that we should try? We should try number 2. So we have seen from here something important. What is the important thing that we have seen here? The important thing that we have seen is that if we put in 1 here, remember 1 here is shown here, then this determinant will create problems. This is the part that appears here. So why we don't remove that 1 from here? And let's try again with another matrix. So let's do it. So okay, here I have the matrix B equal to, remember, the problem was this one, because this one will create this structure and this part is problem because it is reducing, subtracting. So for we have to try to obtain the determinant equal to 2. So what is the idea? The idea is just to put 0 in that part. Okay, and again let's put 1, 1 and 1 1. Okay, so what will we put here? We know that if we put 0 and 0 here, then what will be the result of the determinant of b? So 1 by 1 0 1 1. Okay, we'll put 0 just for generality, but it won't matter in this case. 1 1 1 0 1. Okay, so the determinant of this matrix is 1. Minus 0 by the determinant, we don't know what is it, but it doesn't matter. And 1 multiplied by 1 by 1, 1 minus 0 by 1, 0, so this will be 1. And making calculation, we will have 2. Okay, so we have shown that the determinant of b is less or equal than 2. Okay, remember that a is equal to pi multiplied by b. So the determinant of a is equal to, here we have to recall some properties of matrix determinants. In this case, for example, if we have a scalar multiplying a matrix, then the determinant of the matrix is just equal to the scalar at the same dimension of the matrix, so p at 3 multiplied by the determinant of the matrix b. From the shown previously, so it must be equal to less or equal to pi at cube multiplied by 2, or more 2 pi at cube. What is the matrix that can achieve this? We will put the example here. It's the same, mostly the same than matrix in B, that instead of 1 we will put just pi, and it helps us to show that the equality can be attained in this inequality, and of course it gives us the maximum value of the determinant for this set of matrices. So this is what we require to here. We have obtained the solution of this problem. So it's a very nice problem because we had to think more about it instead of making just algebra. So if you have an interesting solution that you want to share with us, or if you want to extend the problem for n by n matrix, which can be a nice problem too, so please post them or tell us your approach to this interesting problem. And thank you so much. Have a good day to everybody. See you later.